Hello, 1 July the 1st. Alright, let's do this. Alright, so hard problem, never done it before. We're gonna set a hard limit of 10 to 15 minutes. Then we go for the hints. Then we go for copy and paste. Alright? Yeah, that's how we're gonna do. Yeah, we have to really make sure we don't overdo it. Alright, find the original typed string. The type of specific string on a computer, however, tends to be clumsy and may press a key for too long, resulting in a character being typed multiple times. You're given a word which represents the final output displayed. You're also given a positive integer k. Return the total number of possible original string that Alice might have intended to type if she was trying to type a string of size at least k. So it's similar to what we had yesterday. Well, what do we have yesterday? There's no limit. Might have the total number of original. This is a total number of possible original strings that Alice might have intended to type. Total number of original strings. That meant if she was trying to type a string of size at least k, so it has to be at least size, like say here is at least size 7. So we have AA, BB, CC, DD, right? So we have, 2, 2, 2, 2. So in the previous is this also just one character being typed multiple times? This is not a good example. Here. Okay, go to 3. I think it's not one letter. It could be any letter. Right? It could be any letter. So like we have 3 and 3. So technically this position we have 3. So technically we have 3 times 3 equals 9. Right? And 3 times 3 equals 9. So the smallest is AB. This one we cannot do, right? But we can do, AAB, right? AAAB, right? Or ABB, AABB, AAABB, and then ABBB. Yeah, you get the idea. So this one is no good. Everybody else is good. Okay. So basically, we do the same thing. Okay, I should try 1, 2, 3, 4, 5, 6, 7. Yeah, this is only one way. So we still do our way of finding the consecutive counts, right? So we have basically an array of consecutive counts, and we'll skip the ones because we don't really need ones. So we have the counts. We have C0, C1, C2, I don't know, Cn. We have all these counts. Alright, so we have these counts. So, and we need to make the size. So basically, what type of combination will make the size too small? Well, we can find, like, if everybody's 1, so that's the smallest, right? That's the smallest. Okay, so everybody's 1. Then we get to the minimum. And if the minimum is already larger, then we can just multiply everybody. Right, then we're done. But if the minimum is too small, and that means we can assign numbers, right? We assign numbers to make it reach. So we see how much we need to assign, or maybe it's easier to do the reverse style, like how many ways we can get it below k, right? K is a relatively small number, so how many we can get below k? So it's like if I keep this as 1, so we need to find the number of ways that this can make it smaller than k. And then we say, if this is 2, then we want to say these make it smaller than k minus 1, right? So we can say a dp index, right, dpi j is the number of ways, number of numbers, right? The number of words for word, say I to the n, that can make the length smaller than j. So now we add them together here. Right, now we move on to the next one. Yeah, we'll do a consecutive thing. Right, we'll do a consecutive thing, and then so at the end, right, so this will be like three, right? So if I want to do this dp, that doesn't matter. So j shall be, okay, this is 3. 0, 1, 2, actually we need 3. Right, 0, 1. So I start from 1, right? The number of ways to make it length smaller than 3, smaller equal to 3, because we are at this position, right? This position we have 3 repeats. So the number of I can make it smaller than, I want smaller, so actually I don't need this. So smaller or equal to. Yeah, we can do smaller or equal to. Yeah, smaller or equal to. So smaller or equal to 2. Right? Hold on, let me think again. Smaller or equal to. No, it has to be smaller. Hold on. I think we still need it. Smaller, not smaller, equal to. Smaller than 3. Okay, smaller than 3. So at this position, smaller than 3. So I have 2 ways to do a smaller than 3. Right? Smaller than 2, I have 1 way. Smaller than 1. Smaller than 1, which is empty. We have 0 way. Yeah, I don't think we need to consider this part. It's alright. So starting from this position. Oh, hold a second. Oh, yeah. Because we're at the last position. Because the last position we can do this. So now we're at the first position, right? First position. Now we say, I need to make it smaller than, I want to know, starting from the front, the whole thing, right? With the length smaller than 3. So I say I do 1, so it will be dp1 smaller than 2. Right, I pick 2, that would be dp1 smaller than 1. And I'll pick 3. I cannot pick 3 because it should be smaller than 3. So yeah, so here dp1 2, that's a 1. I have 1 way. dp1 is 0. So these are all 0. There's only 1 way to get it smaller than 3. And to get it smaller than 2, it'll be the same. I do 1. So it's actually 0. There's no way to get it smaller than 2. So I have 1 way to get it smaller than 3. And then the total is 9. 9 minus 1 is this. Okay. Let's try this. Basically 2, 2, 2, and 2. Alright. So and 1, 2, 3, 4. So 0, 1, 2. Right? 0, 1, 2, 3. It has 7. Okay. So starting from the bottom. So the number of ways to make it smaller than 7, we'll have 2 ways. 2 ways. 2, 2, smaller than 3 is 2 ways. Smaller than 2 is a 1 way, and 0. Basically, this is 0 until I hit, and then I just be the same. So here, if I take 1, right, so I need to know smaller than 7, just need to know smaller than 6. Right, smaller than 6. Because I take 1, then we need to do dp 3 because I want to know so it would be this. All right, so for this one, it would be 2. Right, and if I take 2, then that will be 5. Right? Because I want to find a number smaller than 7, so it's 2 plus 2. Right, so basically I have, this is 4, because if I take 1, then I do this. If I take 2, I do this. And that's it. So here's the same. If I take 1, I do this. I take 2, I do this. Right? So I take 1, I do this, so these 2. This will be, I take 1, will be this. I take 2. Right? I take 2. So I need to be smaller than 2. I only have one way smaller than 2. So this is actually 3. Right? So this will be these 2. There will be 1. Right? Because 1 is here. And then on this, smaller than 2. There's no way it's smaller than 2. Because I just add this and this. Right? This and this. So yeah, we can actually pre-do, these are zeros, right? So this is going to be 0. Okay, so here is going to be these 2 add together. These 2 is 7. These 2 is 4. These 2 is 1. These 2 is 0. Right? And here, these 2 is 15. That's it. Right, start from 0 is 15. And then we do 2 times 2 times 2 times 2 is 16. All right, so 16 minus 15 will give us 1. That is not right. That is not right. Should be this, right? Okay, this is right. All right, how many different ways we can have it length smaller than 7? We have 1 or 2, right? 1, 2, 1, 2, 1, 2. This is 1, 2. That's just gonna be 1. I think this one is right. So here, right? So if you take 1, so this can be, 1 or 2. They both also have 2. If they take 2, then we need to find smaller than 5. So this is 4, right? We have 4 ways. Basically, we have, CD is smaller than 7. CDD is smaller than 7. CCD and the CCDD, right? So that's why this is 4. And this is the same because the maximum is 4. So this is 4, this is 4. And this is 3. Yes. This is 1. Yes. So this one is also right. Here. Okay. So basically say, okay, I'll have a B. Right. So remaining CCDD, how many can you make such that our total is smaller than 7, just how many we can make the total smaller than 6? Well, the answer is 4, so we have a 4, right? And now I say I take BB, how many we can make such that its length is smaller than 5. So I have 4, right? So that's why this is 8. Right, that's why this is 8. So now coming here. Right, how many gets like smaller than? Oh, I think we can take 0 in this case. Right, we can take 0. So that will be like 3. And that would be too much. 3 times 3 times 3 times 3? That doesn't make any sense. So how many can be smaller than 6? So I take 1, then I need to find how many can be smaller than 5, which is 4, right? Then I take 2, then I need to see how many is smaller than 4, only 3, so this is 7. So this one also looks right. And now we say here, so basically we say we take an A, right? Among the rest, B, B, C, C, D, D, right? I want to know how many you can take that's smaller than 6. Right, that's smaller than 6. Then you find it. You have, 8 different that can make it smaller than 6. Which is, we have the CD, CCD, CDD, CCDD, and then we can have a B, then we can have like BB, right? We have this. So at A, we take 1A, we take all of these. That's 1, 2, 3, 4, 5, 6, 7, 8. That's 8. Right, so you at least have this much. Oh, I see why. Because you can do length 7. Wait, hold on. Yeah, you can do lengths. I'm trying to do all different types. Alright, and then you do A. I put A ahead of it. These are all things that's 2, 3, 4, 5, 6, 7. Huh? 2, 3, 4, 5, 6. Oh, the last one shouldn't count. Wait a second. We find some issues. Why is this one here? That shouldn't be 8. Like with a 1B, we got this, right? Then we get 2 B's. Right, we get 2 B's. That is right. Right, that is right. That's smaller than 7. Yeah, you got 6, which is smaller than 7. So all of these are smaller than 7, right? All of these are smaller than 7. Oh, shoot. That was right. It's not these two, it's these two. That's 11. Then 16 minus 11. That'll give you 5. Ah, now it makes sense. So I just need to do this one. right? And then I can change, right? Change, and change, right? Until we get to the last. Okay, I think I might be able to solve this. And we still have like 5 minutes. Use DP, where DP, well, first of all, produce an array, right? Produce an array that counts the number of consecutive letters that are the same from word. Then use DP on it, where dpij is the number of ways, right, to make a string, to make a typed string, starting from the ith position, call it consec, from consec I to the n, with length smaller than j. Eventually, when we find consec 0, k, we can compute the result as consec 0 times consec 1 times consec m minus dp. This is not consec. Zero k. The dp array can be simplified as a 1d, Yeah, I think. Well, let's give this a shot. So sec.pushback current equal to 1, else current plus plus, right? So if the same, current plus plus, move to the next one. If they're not the same, I push this in, I reset current, right? So blah blah blah. Once we get to the end, we need to push the last current. Okay, so that's conseg. Now I'm gonna do dp. So dp is going to be size k. Okay, dp is going to be size k. And then I'm going to do the last round. The last round will always be starting from this, right? And it will keep going. So 0, 1, 2, right? 0, 1, 2. So for that, so we're going to say for int I equal to 2, I smaller or equal to k. Then we have to go k plus 1, right? I plus plus. Then we say dpi shall equal to I minus 1 std minimum I minus 1 and conseg dot size minus 1, right? So yeah, so we start from here, there'll be 1, there'll be 2, and then we take the minimum. So once we hit the minimum, we don't go. So we fill it out, and then we say for int I equal to, so what will be conseg dot size minus 2 I larger equal to 0 I, actually larger equal to 1 I minus minus. In fact, because I only need to know these two, right? So I can terminate early. So in this one, I only need to go, so yeah, so this requires these two. So k needs to go k minus this and k minus this. Minus 1, minus 2, right? So this needs this one minus minus, so minus minus. So basically at each level, right, at each level, now that's fine, just whenever we hit 0, yeah, we stop, or whenever we hit 1, we stop. Whenever we hit 0, we stop. Yeah, whenever we hit 0, we stop. Okay, so for, yeah, we go for this one, because otherwise we get these two, this one will get these two. Yeah, we do that, right? And what we're gonna do is we will go from right to left. J shall equal to dp dot size minus 1. J large equal to 0. Right, and dp j is larger than 0. J minus minus. Okay. And then we say dpj, we need a mod. Okay, so we say dpj shall equal to dp j minus 1 plus dp j minus 2. So actually they should be large equal to 2, right? Large equal to 2, it cannot be smaller than 2. So yeah, we do that. We say this plus this mod. Yeah, just to prevent. Let's go long on the mod. So yeah, this dp is long, and everything's fine. So dpj, right? This equal to this right? And then we move on, and once it becomes 0, we'll get out. So we do that. Okay, we do that. Once we're done, we can say long to remove shall equal to dp k minus 1, right? So it's this and this. So k minus 1 plus dp k minus 2 mod total is just this times this times this times this, right? So I say for int count of consec so what we're gonna do is total equal to total times for the long C mod. Okay, and at the end we'll return total minus to remove plus mod. Something like that. Let's see. Okay, that looks good. Let's try it. Okay, we have only one, and yeah, I did not consider this. So this consec will be 1. K is 1, so we basically have 2, right? 2 columns. 2 columns will always be, so this, because I have to go with this, so consecutive dot side is 1, so this I don't do, right? So this one basically doesn't exist because K is, okay, so if K equal to 1, if K equal to 1, so at least 1, right? So K equal to 1, the answer shall be the total, right? K equal to 1, the answer shall be total. K equal to 2, I think I can do it. K equal to 2, I think I can do it because the consecutive could still be nothing, but I have the bottom row, right? If K equal to 2, and if it's the same thing that's repeating, actually we can try, right? We can try. So we can probably get this one earlier. Okay, so we'll get this one earlier. All right, and then we say if K is equal to 1, because that's guaranteed to be 0, right? Then we just, return total. Otherwise, we do this exercise. Yeah, we'll use this test case, and in fact, I think it'll be interesting to use this. Now we'll go 1, 1, 1, right? And I have some, let's say we have this 1, 2, maximum 8 test cases. Okay, so we are going to reduce a few of them. I'll run it. Let's see. Line 21. You need a consecutive first. Okay, yeah, that makes sense. So I need the get a consecutive first, and then we do this, right? Then we don't need to do dp if k is equal to 1. Okay, so this is not right. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10, right? This is k equal to 2. Okay, k equal to 2. So basically, there's just 1 here. All right, so dp2 is going to be 1. Okay. And consecutive size is 1. So I don't do anything because everybody else will be 0. Actually, this is not going to be 0, right? Because here it's going to, yeah, this is going to be 0. Everything's going to be 0. K is equal to 2. Yeah, k is equal to 2. We only have one number. So to remove is k equal to 2. We don't have it, right? So basically we say this is if k is larger than 2. Then we go through this. Okay. I have what it takes. So basically we go back to 0. We go to 0. We just fill them all out, right? We fill them all out, and then we know it's just going to be dpk, right? So we can just call it dpk. So we don't even need this one. Just we go to the top. It'll save us some trouble. All right. Try it again. Okay, we pass a few, but okay, what's this? This is a QWW, so we have a 1, 3 situation. Okay, 1, 3 situation, k has to be equal to 4. Okay, so yeah, we have basically this 0, 1, 2, 3, 4, 1, and then we'll go from 1, 1, 1, 2, 3. Right, that's the bottom layer. So we go here, smaller will be this 3, and here, so we can do 1. Oh shoot! Oh shoot! We have to. Oh my god! Yeah. Blah blah blah. It's just 2. Because you only can do 1. You don't add them together. So this is 1. This is a 0, right? So the answer is 2, and this is 1 times 3. So the answer should be 1. Is here we got something wrong here. Oh shoot! Then we have to do prefix sum, right? Because the count can be gigantic, right? The count can be depending on the value here, the value can be huge. Then we should need to add all of them. Ah, Lord. Ah, Lord. Yep, we have to do a prefix sum. Well, if we do prefix sum, then we go from left to right then. Right? We have to go left to right. Oh my god. This is not good. This is not good. This is not good. Prefix sum. I do this. I mean, technically we can still use 1. Because we change this and it's this, right? This is this, okay. But after we go through the whole thing, we need to run it another time. Okay, wait, just do prefix sum. Okay. Yeah. I forgot. That's like, I forgot. Okay, so that's fine. So this is okay, but we need to do prefix sum. Okay. So dpi shall equal to Lord, dpi minus 1 plus this. Okay. In the implementation, we use 1d dp and we make the dp array into a prefix sum. So prefix sum, do this mod, right? So this is prefix sum, and then this is fine. This is fine, right? But here is not fine. This is not right. Okay, this is not right. So I need to redo this. So what is this part? So this basically is the part where you need to know, right? Where you need to know the dp. So it will be dp j minus 1, that's fine, minus dp something plus mod, and then mod, right? That's what this one is. And this one is also a little bit more complicated because it depends on whether we have enough, right? So this is going to be, because I can take, right, the current I can take 1, so minus 1, up until I can take whatever the current value is. I can take 2, right? So it should be j minus consec I, right? But then j minus consec I have to do, because it's from this plus, so it has to be minus 1, right? Now we need to consider if this is larger, equal to 0, right? If it's smaller than 0, then we should do just 0, right? So we have to say like j minus consec. Oh. Okay, let's do this. low shall be j minus consec I minus 1. Right, and then we can do high shall be j minus 1. So this is going to be high, and this is going to be low. But we say low, if it's larger or equal to 0, then we can use it. But if it's not, it's just going to be 0. Right, so this is to use prefix sum and indices, right? Indices, the boundaries of prefix sum. So yeah, so we do this minus this plus mod. So that's that. Now once this is done, now we're gonna redo the prefix sum. Right, we're gonna redo the prefix sum. Basically, we say for int j equal to 1, j smaller than dp dot size, j plus plus, right? What we're gonna do is dpj shall equal to dpj plus dpj minus 1 mod. Right, so we need to restore prefix sum. Right, dpj plus this mod, and at the end we do that. All right, so we have a little fix. All right, we're hitting 1 hour mark, so let's test case. All right, let's just run this, see if it make any sense. And we have lots of issues. Did we overflow or what? Oh, restore. My bad. So basically, so it has to be dpk minus dpk minus 1. So I say, yeah. There we go. All right. Try this one. Ah, shit. Ha! Well, we tried. We absolutely tried. But it times out. TLE. Ugh. Well, we tried. Maybe there's room for improvement. I'm not sure where the improvement will be. Well, we go. So we don't go from right to left, we go left to right. And you don't have to do it twice. But you will have to create another DP. Maybe we can use 2 arrays, right? Use 2 arrays to restoration of prefix sum. Yeah, there's hope in this one. So what I'm gonna do is I'm going to copy and paste, but I'm gonna try this one more time. Right, because I do believe this one can be done. Okay, this is copy and paste. But I think my method might work. I just need more time. I just need more time to work it out. So yeah, let's submit this one first. But I want to check. I cannot use this as a test case, can I? And let's delete one of the test case. Use this as test case. I mean, we passed 832. Not too shabby, right? Well, let's submit it. And I'll redo this. So yeah, we'll come back to this solution. So yeah, I have one way to make it faster. Maybe we'll produce another array. So we'll go left to right. So we'll get the prefix sum along the way, so we can save this part, so we don't have to restore. And that might work. That might finally push it against the limit, maybe. So we'll see. We'll see. I think there's a lot of hope in this one. Copy to editor. Oh wow, good feature. Okay, that will be it for now. I will find some time to work on this again.